Hello everyone. In this section we will discuss the various operations of TensorFlow. So in the following given table of content, first we will discuss what are mathematical operations in TensorFlow, and then later we will discuss various operations of TensorFlow. So before we are going to discuss the various operations of TensorFlow, first we will discuss the tensor structure. So basically tensor structures consist of three parameters, that is rank, shape and type. Rank identifies the number of dimension of the tensor and it is known as the order of n dimension. So the next one parameter is shape. The shape of a tensor is the number of rows and columns it has, and type identifies the data type which we have assigned to tensor element. Now we will discuss our first topic, that is what are mathematical operations in TensorFlow. So basically numbers in TensorFlows operate the same way they do in real life. You can use them for addition, subtraction, multiplications, divisions. These are the basic operations which we are going to use in a TensorFlow. You can perform any equations in TensorFlow that you can use in real life, and even a few that you can't. The great thing about TensorFlow is that you don't need to actually perform math operations. The functions that we are going to use, they can easily perform. Now we will discuss some various operations of TensorFlow. So TensorFlow requires various operations to be performed in a mathematical calculations. The operations perform certain calculations on the tensor. So following is the list of commonly used operations, and each operations require one or more arguments. Now let us discuss about these functions. So the first function is tf.mat.add. So basically this function is used to get the a plus b, that is our input tensor, that pass to the function, and it is used to add two input tensor together element wise. So here is the syntax of tf.mat.add function, and within this function there are mainly two parameters. The first parameter indicates the first input tensor, and the y parameter defines the second input tensor on which the addition functions will be applied. The last one parameter is name. By default it takes a none value and it specifies the name of the operations. Now we will look some examples and understand about this function. Now before taking an example of tf.mat.add function, we are going to discuss the tensor structure. We have already discussed about the shape, type and rank attributes. Now we will understand about this example. So for this we have imported the tensor library with the alias name tf, and then initialize a tensor by using tf.constant, and within this function we have assigned the integer elements as an argument. As you can see that integer values has been represented as 13, 56, 78, 9. Now we want to display the rank of tensor. For this we are going to use the dot and dim attribute, and if you want to check the shape of a tensor, then you can easily use input tensor dot shape. Input tensor is a tensor name and dot shape is a attribute that displays that how many elements which are available in the given tensor. Now if you want to check the data type of tensor, then you can easily use input tensor dot d type. It will display the data type of a input tensor. So after executing this code, as you can see that the output comes the rank of input tensor, that is 1, because it is a one dimensional array, and it displays the shape of input tensor, that is 6. That means it contains 6 elements in the tensor. After that it displays the data type of input tensor, that is integer 32. Now we will discuss about the tf.mat.add function. So basically in this function, first we have imported the TensorFlow library with the alias name tf. So next we have created a variable in the form of tensor by using tf.constant. So in Python this function take a constant value that represents the value and does not modify. So in this case I have used the scalar value, that is 67. Along with that I have mentioned the data type, that is int32, and the name of the operation, that is val1. Similar in the case of second input tensor, I have created a input tensor by using tf.constant function and assigned the scalar value, that is 89. Along with that I have mentioned the integer 32 data type and the name of the operation, that is val. So in this example we have created a session like tf.session, but this is the latest version of TensorFlow, so we have used tf.compact.v1.session, and it launches the session as val, where val as the session name. For this we have imported a tf.compact.v1 disable eager execution function. So after executing this code, the output comes the addition of two input tensors, that is tens1 and tens2, and it displays the output, that is 156. Now we will understand the tf.mat.subtract function. So basically this function is used to get the subtraction of input tensor element wise. So here is the syntax of tf.mat.subtract function, and within this function we are going to use mainly two parameters in our example, that is x and y, and it specifies the first and second input tensor on which the subtraction function will be applied. And the last parameter is name. If you want to give the name of the operation, you can easily use it. So it performs the name of the operations, and by default it takes a none value. Now we will discuss an example of using this method with the help of a tensor. So similar in this example, first we have imported the TensorFlow library with the Elise name tf. In this example I have created a session. For this I have used the tf.compact.v1.disable eager execution function. After this I have created two input tensors named as inp tens1 and inp tens2. So within this variable I have used tf.constant function for creating a tensor, and within this function I have used the scalar value, that is 30. Along with that I have mentioned the d type, that is integer 32, and specifies the name of the operation, that is val. Same in the case I have used the second input tensor and assigned the scalar value. Now for getting the subtraction of two input tensor I have used the tf.mat.subtract function, and within this function I have passed the input tensors as an argument. So as you can see that the output comes the subtraction of two input tensors, that is 18. Now after understanding the subtraction function we will discuss tf.mat.multiply. So basically this function will help the user to multiply element wise values in the form of x into y. So basically if you want to multiply the tensors and get the result, so to do this we are going to use tf.mat.multiply function. Again this function takes mainly two parameters that specifies the input tensors, and the tensor must be an integer or floating data type. Now let us understand the implementation with the help of an example. So in this example as you can see that we have similarly imported the TensorFlow library. After importing the TensorFlow library we have used the tf.constant function for creating an input tensor, and within this function we have assigned the scalar value, that is 34, and assigned the data type, that is int 32. If you want to change the data type you can change it, but data type must be an integer or float. You can also change the value of input tensor in the form of decimal value, and name of the operation is tens1. Same in the case of second input tensor, we have assigned the scalar value, that is 26, in the data type of integer named as tens2. So now I want to multiply both the input tensor. For this I have used the tf.mat.multiply function, and within this function I have assigned the two input tensors, tens1 and tens2. So getting the result I have created a session, that is tf.compact.v1.session, and val is the session name. So within this val I have passed the result variable as an argument. So as you can see that the output comes the multiplications of two tensors, that is 884. Now we will understand our next function, that is tf.mat.divide. So basically this function will help the user to calculate the division of two input tensors, and it can be divided with the scalar value, and you can create a list or tensor in the form of one dimension. So here is the syntax of tf.mat.divide, and within this function we have used two main parameters, that is x and y, and these parameters defines the input tensors, And name parameter, it is an optional parameters and it specifies the name operations, and by default it takes a none value. Now let us take an example and understand the working of tf.math.divide function. So here is the example. In this example, first I have imported the TensorFlow library with the alias name tf, and for creating a session I have imported this one, tf.compat.v1.disable eager execution. So after this I have created two input tensors for dividing the element. First one is tens1 and second one is tens2. For creating this I have used the tf.constant function, and within this function I have assigned a tensor in the form of a one-dimensional tensor, that is 55, 88, 22, 33. Along with that I have mentioned the data type, that is integer 32, and name of the operation, that is tens1. Now if you want to calculate the first input tensor, now after creating a first input array I have created second input array, that is tens2, and specifies the integer values in it. So now I want to divide the elements of first input tensor with second. So for this I have used the tf.math.divide function and passed the input tensors as an argument. So as you can see that after executing this code, the division of two input tensors is 11, 11, 11, because if you divide the 5 with 55, the question comes 11. Now we will understand our next function, that is tf.math.power. So basically TensorFlow tf.power function can compute the power of one tensor to another element wise, and it can be given the power of scalar value. So here is the syntax of tf.math.power function. So basically this function takes two parameters that defines the input tensors. Now we will take an example by using tf.math.power function. In this example I have imported the TensorFlow library with the alias name tf. After that I have created a first input tensor named as random num by using tf.constant function, and within this function I have assigned a two-dimensional. So after this I have created again the second input tensor by using tf.constant function. So now I want to get the power of a given input tensor. So for this I have used the tf.power function, and within this function I have assigned the input tensors as an argument. So after executing this code, as you can see that the output comes the power of a input tensor. Now we will understand our next function, that is tf.math.exp, that represent exponential. So basically it is used to calculate exponential of x element wise, and an exponential value is calculated by y equals to e raised to power x, and the module TensorFlow.math provides support for many basic mathematical operations. So here is the syntax of tf.math.exp function, and within this function there are two main parameters that defines a tensor, and the data type must be a float or complex value. Now let us understand this implementation with the help of an example. So in this example I have imported the TensorFlow library with the alias name tf. So after that I have created a tensor by using tf.constant function, and inside the function I have assigned the decimal values, that is negative and as well as positive value. Along with that I have mentioned the d type, that is tf.float32. So after creating a tensor, now I want to display the exponent of these input values. So for this I have used the tf.exp function, and within this function I have assigned that input tensor and along with that name of the operation, that is exp. So after executing this code, the output comes the exponential of input tensor values. So our next function is, that is tf.math.round function. So basically this function is used to calculate the round value of the input tensor, and it is done with an element wise. So in simple words, it will return the round figure value of an input tensor nearest integer value. For example, suppose you have an input tensor 9.666, and after using the tf.math.round function, it will display the rounded figure value, that is 10. So here is the syntax of tf.math.round function, and this function takes only one parameter, and that is tensor input, whose round value is to be generated, and it can be of type tf.tensor. Now let us take an example and understand the working of tf.math.round function. So in this example I have created a tensor by using tf.constant, and within this function I have assigned the floating values, that is 9.567, 2.8997, 3.678. Now I want to display the exact value. For this I have used the tf.round function, and within this function I have assigned the input tensor as a parameter. So after executing this code, it will display the rounded values of input tensor, that is 10, 3 and 4, and the shape of the input tensor is 3. That means it contains only 3 elements along with the data type float 32. Now we will discuss our next function, that is tf.maximum. So basically this function is used to get the maximum value from the input tensor, and it reduces the given input values along the dimension of axis. So here is the syntax of tf.maximum function, and this function takes only one parameter, and it is the tensor input whose maximum value is to be generated, and it can be of type tf.tensor. Now let us take an example and understand the working of tf.math.maximum function. So in this example I have created an input tensor by using tf.constant and assigned the list in it. So next I have created a second input tensor by using tf.constant function and assigned the second list. Now I want to display the maximum number of elements according to the list. For this I have used the tf.maximum function. So within this function I have assigned input tensor values. So after executing this code, it displays the maximum input tensor. So now if you want to get the minimum input tensor, I am going to use minimum function. So after executing this code, the output comes the minimum input tensor, that is first input 12, 56, 78, 92. So with this we have completed the various operations of TensorFlow.